and parts of Canada. This eruption reduced the height of the volcano by 1,314 feet and left a large northward-facing horseshoe-shaped crater. While this represented North America's costliest volcanic eruption, it was neither one of a kind or unusually large in comparison to prior eruptions. As Mount St. Helens is not only the volcano with the second highest number of Plinian VEI 5 or larger eruptions of any volcano on the planet during the Holocene epoch, but also another lateral blast incinerated 75 square kilometers or 29 square kilometers of the volcano due to an eruption around the year 800. This is why Mount St. Helens is rated as second highest threat volcano in the United States, earning a very high threat designation. Even smaller eruptions of this volcano given the correct set of circumstances could generate long-reaching lahars which destroy homes, roads, and bridges. And yet, despite its still fairly large size, rising more than 6,000 feet above the surrounding landscape, you might be surprised to learn that Mount St. Helens is a relatively new stratovolcano, if we are talking on a geologic timescale. Eruptive activity at Mount St. Helens has been dominated by four distinct, several thousand-year-long eruptive periods where frequent volcanic eruptions occurred only to be followed by 3,500 to 15,000 of years of no distinct eruptions occurring. The first eruption of Mount St. Helens occurred 40,000 years ago, approximately 53 miles east, geologic history, northeast of what is now Portland, Oregon. In what was already a mountainous region, viscous andesite and dacite lava then erupted, forming a closely spaced cluster of steep lava domes. These eruptions emplaced large amounts of lava, building the base of the volcano. These eruptions continued intermittently for another 5,000 years, the latter stage of which formed the beginning of what would become its central vent. No eruptions occurred for the following 15,000 years until what is known as the Cougar stage of volcanism began 20,000 years ago. The first of these eruptions caused the prior debris avalanche central cone to catastrophically collapse to the south in a massive debris avalanche comparable in volume to what was observed in 1980, filling some valleys with material up to 900 feet thick. This then gave way to a powerful Plinian eruption, which distributed ash over a wide area. More lava-effusing eruptions then followed, the last of which produced the most voluminous lava flow in Helens's history, an up to 200-meter-high and 6-kilometer-long andesite lava flow which originated from a still visible vent that at the time marked the 6,000-foot-high summit of the volcano. The next eruptive phase occurred from 13,000 to 8,000 years via the growth of dacite lava domes that produced frequent collapses, ejecting ash and increasing Mount St. Helens to 7,000 feet in height. The final eruptive period began 4,500 years ago, meaning that everything above last 4,500 years 7,000 feet elevation formed in this timespan. Numerous andesite and dacite lava domes were emplaced during this eruptive period, and glaciers grew on Helens's edifice. Interestingly, despite the explosiveness of this volcano, between the year 105 and 260, three basalt composition lava flows erupted from the summit and flanks of Mount St. Helens, which would go on to travel up to 9.8 miles from the volcano's summit in runny Pahoehoe lava flows which may have lasted for several months each. The longest and most voluminous of these primarily effusive although perhaps moderately explosive eruptions which may have seen Strombolian eruptive activity occur created what today contains the Ape Cave lava tube. Since 1400, Mount St. Helens has produced Plinian eruptions in 1480, 1482, 1800, and 1980. Several small lava dome and flank andesite eruptions occurred in between the majority of these, with the last such eruption occurring between 2004 and 2008. As a final note, I would like to thank my new patron David Wood for supporting this channel.